There we go. All right. Welcome everybody to this week's meeting. It is finally summer. I'm sure we're all pleased about that. Um, we don't have any new members to announce this week. So I think we'll head straight into the presentation. I see that Xavier is on the call. So I will let him introduce himself and take it away.
Yeah, thank you, Dan. It's exciting to join and be able to share a bit about our project here. So might not be the full 30-minute presentation, but I'll go through kind of what we've been working on, already been working with some of the folks here, happy to say, and excited to kind of keep growing with that. So yeah, guess I'll just jump into it then. Yeah, so I'm Xavier Abalkatsuge of Picetta Systems, assuming folks can see my screen here.
Yes, we can see it.
Yeah, so what I'll talk about today is just syncing nutrient supply to plant uptake with the project that we're building at Picetta Systems, which is the lens for real-time plant tissue analysis, and go through a bit of why we're doing this, some results we've gotten from the past, as well as some kind of responses from growers. So should be an interesting presentation here. So we started out being scouts in the east coast of Canada here in New Brunswick, going out on a weekly basis and picking up samples from petioles. We do this because potatoes are very actively managed. We're applying foliar every week, but we saw the lag in time to send the tissue sample to the lab that was in Ontario, and then waiting maybe a week or two to get results. By that time, you're kind of already on the next application, and it was more of like a report card, so to say, rather than something that can really inform what you're going to be doing that day. So from this experience, we saw there was an opportunity here, and then we actually were completing our engineering degrees at UNB and decided to dedicate a whole year to looking into this problem. From that, we had a prototype and got started working with local farmers from New Brunswick, as well with the Institute of Optics to develop a solution for this. So we think with what we're building here could be applied not just to potatoes, but to crops broadly to be able to dose fertilizers much more precisely than what we're doing now. So how do we do this? Well, we think if you know your crop, you can grow your potential. With the lens, you can detect deficiencies for all the nutrients, so you can actually see what's going on. The goal, of course, is to improve yield, reduce emissions, as well as being able just to track performance of your field over time in a way that you could only do on research plots beforehand. But to be able to get that level of data on commercial fields can really unlock a lot of things for both farmers and just research in general. So this is it. This is the lens. We have it all, the technology into a case. And what we've done is made it super easy to use so that we can train a scout within a couple hours, maybe an hour or two, take a demo test, and then they're ready to scan leaf tissue directly. There's no sample preparation, only make sure that you're picking the right leaves from your protocol, so the most recently matured growth most of the time. There isn't any visible signs of damage. Then with the probe there, there's light source and fiber optic coming from it. Then you would directly on the leaf tissue scan it, take 10 to 15 leaves from your sample area. And from there, we would be able to do a sample report for it. So the benefits here would be to monitor trends. Like I mentioned, actually saving time sampling. We've seen folks cover twice as much ground in the same amount of time as scouts, just because you don't have to bag tag, ship samples out. Of course, the end of the day, what's important is the outcomes to the farmers. So being able to save on unnecessary sprays, or when you are spending on more sprays, they're exactly what your crops need. So if you're getting a benefit out of it, then that's the whole goal, right? The sustainability aspect comes from precision agriculture. When we're trying to do is reduce unnecessary sprays, right? So if we can reduce nitrogen application when it's not needed, that's a big emitter in the food process, food creation process. Then trying to make the results easy to understand so that when you're an agronomist, you can communicate that to the growers. Most of our clients are typically independent agronomists, co-ops, retailers, those types of service organizations that serve a bunch of farmers. So for them to be able to communicate what's going on to 20, 30 farmers is pretty critical. So this is what, with those 10 leaves, you would get in about a minute or two. You would get nitrogen, nitrate, phosphorus, potassium, magnesium, calcium, sulfur, manganese, boron, zinc, copper, iron, and aluminum. And right now we have it calibrated fully for potatoes and corn. And one of our big projects is to be able to do it for most of the large crops in agriculture. So our R&D right now is looking at how can we add wheat, soy, canola, and other types of crops similar to it, onions, celery, carrots. We want to be an every crop eventually, but starting with the ones that we know the best, and then expanding from there. With these reports, it's not just getting a one-off report, but we actually have the platform so they can see results in context. So right when you get that data, both the scout, agronomist, and farmer can see the results as well as on the critical levels. So taking these first from kind of what's used in industry right now with the critical levels, we'll actually be adding a tool pretty soon in the next month or so that agronomists can take these critical levels and shift, let's say emergence is late or early, just being able to adjust the time frame with what they're seeing in the field in the growth stage, as well as adjusting it to their specific region or experience. So actually letting them craft their own critical levels, which we're pretty excited for. So that should be released in the next month or so, once we're just done with the development process here. And yeah, it should be mentioned, it could also be exported as PDF report, Excel file, CSV, or through direct API, which is pretty useful if you're already using other platforms. So here's some data. We got some data folks in the room. So this was our initial results in corn from our testing last year. And then what we're trying to do is to create a global baseline, right? So when we scan a corn leaf, we're comparing it to the hundreds of thousands of scans we've done in the past to know what calcium deficiency in V3 looks like, or what does sufficient sulfur in V6 corn looks like, or potatoes or other crops. So per crop.
That's weird. Thanks.
Oh yeah. And if there's any questions, feel free we can talk about it more. But looking specifically at the average difference per crops for nitrogen here in corn, this was our first year, was 1.45%, which we see as very good, being able to track where your nitrogen is over the season based on the real-time results here. With PK, they go up to about 2.8 or 1.9. Which is still quite on with what we're working with to be able to see the trends. So we see this as very useful data, especially when you're getting it much faster. It's much easier to collect. So for sulfur, we were about under 3%. Calcium was a bit higher at 6%. So some of the micronutrients like boron are a bit harder to track. I think the hardest so far has been manganese. But as we're getting more data, we can even get better and better. But for this, we see this as pretty useful for commercial farmers and agronomists to be able to make decisions off of, and that's the response we've had so far. And so with this difference, we're not trying to match the lab one-to-one. What we're trying to do is to build a reliable way to get crop conditions in the field, right? So even with that average difference, if we look a bit deeper into it, one trial we did, which is the chart here on the right, is with the McCain's Farm of the Future from last year. So this was with 250 samples, and what we did was take 2 samples from the exact same spot of the field and send both have them scanned with our sensor and then sending them to the lab, and we got some interesting results on just kind of the repeatability. So with the same area, you would think that the difference wouldn't be too large, but we saw, especially with these three nutrients of nitrate, phosphorus, and potassium, that there were 20% difference, up to 20% difference between the 2 different lab tests, and that's the average over this study we collected, versus with the lens it was more consistent. So what we're trying to do is not just match what the lab's doing, but actually make a way that you can have it consistently, not just with the same lab, but if you think about growing crops, across North America. There's hundreds of different labs. Being able to have just a standard baseline across that, we think is going to be pretty useful. So yeah, just a couple more differences here from what we're doing. Of course, turnaround time, we make it so that you can take unlimited samples. So you can basically become your own independent lab in your truck for tissue testing, and then be able to see that data when you need it. So when you're at that critical step, you want to do a full year application, or what's coming up, you can actually do it right before, and then go measure the uptake a week later. So that's how we see this type of technology being used. And then I'll just finish off the presentation here with a couple of words from folks we've been working with. So for this year, we'll be in about 13 states with 7 different provinces, working with some of the leading independent agronomists, as well as some seed and input companies, just being able to scan potatoes and corn, and working with some pretty great universities and research partners on new crops as well. So this was an interesting setup here, was it last year in Manitoba. So it was actually a spot where there wasn't any cellular, and they had a pretty good setup of having it with the Starlink in the back of their scouting truck. So when they were able to go scout, they would just scan it there, and completely off grid basically, and then growers would get results in just a minute or two, when it used to take 2 to 3 weeks, since it was kind of an isolated spot. Yeah, so this quote too, we've done testing in 4 continents so far. So North America, South America, Europe, and Africa, just a little bit. But this was actually a picture from South Africa there in some of the fields. And yeah, this is just another quote on the effectiveness of it. Yeah, so I know a lot of people in this group already, which I'm glad to say are colleagues and friends. But if this is interesting to you, you would see an application either in potatoes, corn right now, or being able to help us get calibrated in crops, please get in contact. We're always trying to find good agronomists and scouts to work with across Canada and beyond there. So yeah, thank you for this opportunity for this quick presentation. Could do kind of a demo of the platform, or can just keep talking. I'm not sure how we're doing on time here. Yeah, 16 minutes. So maybe not the full 30 minutes worth of material, but hopefully that's interesting for you folks.
Perfect. That's great. Thanks so much, Xavier. We'll open the floor to any questions or discussion if anybody has anything they want to ask.
Yeah, I guess I would have a bunch of questions on with this being an AgRobotics group. You might be wondering why are we here? We're doing kind of a sensor, but we're very keenly interested in working with folks doing robotics to be able to add this capability on robots. And that's not one of our strengths. We're really into signal processing, of course, machine learning, doing tissue analysis, chemometrics, things like that. We're not really much in the agrobotics space. So one of our systems is with Chuck here with Haggerty right now, doing some testing, and we'll be continuing to work both with Chuck and the University of Guelph and a couple other partners, trying to figure out the agrobotics piece. So we're still pretty new to this sort of thing, but plenty of opportunity.
Well, and I think that the fit between what we're doing and what the researchers are doing and what Xavier is doing is that, taking these, we talk about taking the crops to the next level, right? And some of the ideas of these sensors and real-time data is making more actionable items for the producers, and in the horticulture space, in potatoes and that kind of crop, tissue testing is very, very important. In grain crops, it's still very much a novelty. Like, lots of people talk about doing tissue testing, corn and these kinds of things, and they talk about it, but it's not done with any kind of scientific rigor. It's just, I got a problem, so let's send a test to a lab, and by the time I get the results, it's too late. I'm not going to do anything anyways. And so really it's about advancing things, and our interest is in how do we integrate sensors like this into technology, and can we even do it? And if we can do it, what does it got to look like? That's kind of what we're up against.
Yeah, and it's a very interesting point, Chuck, on the different crops. Like from where we started with potatoes, it's religion, almost religion for the big producers to tissue test like every week, basically no matter what. And that was with the very intensive process with having like a couple full-time scouts with every agronomist just dedicated to it. We added corn to the platform this past year, expecting that we would get like a couple of research projects and be able to, keep really focusing on potatoes since that's what people take a lot of tissue tests with. But we're surprised that half of our units this year will be in corn in the Midwest, which is we think is pretty big opportunity if we can get adoption with corn producers. Because right now, like you said, it's a novelty. It's maybe the top percent of like people really going for yield records or like doing very intensive research, right? But if we make it easier, even just with what we're doing now, with just having it portable in a system that you can take a tissue test anywhere, it's not even talking about like having it on a rover or a robot yet, but just that seeing more adoption and people being ready to use it is promising for our project.
Wow. And I think what was of interest, so we did some winter wheat trial, well, which we'll present on at a later meeting. What was interesting about wheat production here in Ontario, what the producers that participated in found is every one of them was excessive on their amounts of N that they were applying. So it's not just about the sensor and its reliability, but it's also about the production system that we're actually using, and going to those producers and saying, okay, are we wasting this nitrogen, and what are we doing here? And the one producer came to me and said, well, I want to put even more N on. And I'm kind of like, well, but all your results show that you're way out, right? But this technology enables these discussions, right? It enables this. Sorry about that, David. I keep cutting you off.
I'll just share a quick example before that, and we'll get to David. I won't just quickly. But it was funny. We were working with a seed producer for nitrogen efficient potatoes, and they had done all this research for a new variety that was supposed to be more nitrogen efficient. They give it to commercial producers, and they did exactly the same applications with everything else, right? So just having that piece to, know what to do when you're in a commercial field, it's a lot different than, when you're doing it in research. But yeah, David, would love to hear.
Yeah, so great presentation. This is exactly the type of precision ag, real-time ag that we need. So first would be just as general suggestion that on your journey to get automated testing put on a robot, is it possible to have just a small portable system that, because somebody has to go and pick leaves in the field, where they go and they pick leaves in the field, pick a leaf, GPS is recorded, scan it, store the data, and then that's all they do. And then it can go back and the data can go be processed so that your leaf picker gives you a geographical spatial map of your samples. So you have both averages for your field and spatial, because fields aren't homogeneous. And so you would need a battery pack, but basically it would be a little device where you walk the field, pick your leaf, scan it. You can do 100 if you want. And somebody does that once a week. And then the data, you either bring it back in your computer pack or you Wi-Fi it to somebody. So you separate your picking and analyzing from your interpreting and calculating. And then obviously go to your robot, where your robot picks a leaf, puts it into a device, measures it, and does it that way, which absolutely is possible. It's just going to be expensive and complicated and take some time. And of course, let's get the robots in the field first before we add that level of complexity. Yeah. But this is perfect. I think this is perfect for, if you're going to have the robot in the field, your end goal has to be measure the plant during the growing season to lower those nutrient costs and do it much better, especially if we want sustainability. So my question is, sorry for being verbose. Why do you think there's so much lab variability in their testing? Because it looks like yours is much more precise. Your standard deviation looks to be much smaller, much more consistent, and theirs isn't. And the follow-on to that is, are you generally measuring lower or higher than the lab, or the same if you do a huge number of tests? Because maybe they're overestimating, underestimating because the type of chemical analysis they're doing, I don't know. So why do you think the variability is there, and how do you calibrate relative?
Yeah, great question, David. So with each lab test they're doing, it's a new experiment, right? So there will be some variability with that inherent to just doing tests, especially that we're training with now a dozen different labs. Even if they're doing the same type of procedure, their type of testing will be different. And speaking to lots of producers, like what they're interested in is less so like, is it 3.8 nitrogen or 3.85? They're more interested in keeping the trend and being able to keep it consistent. So part of it's being just kind of taking the average of all the different labs results that we're getting, adding that to our system so that we can recognize different conditions. Part of it too is that when you're starting to train this type of model, you start by the average, right? Then you be able to be more expressive the more you see. And that's something we've seen, or that's why we need to like start with research projects for new crops. Is that we need to see what super high magnesium looks like. We need to know what really calcium deprived plant will look like as well. And then the models become more and more verbose and then become more useful as folks use them. So it starts out more as an average and becomes louder, more expressive as we see more crops.
Does that mean that you have the capability to kind of self-calibrate to a farmer's operation?
Well, that is the goal. Like part of so a lot of what we do is on just logistics and how can we get this deployed, in a large area. And part of that is just continuously getting more data. So part of the package will actually pay for the first 2 weeks of lab testing with every client. So when they start off the season, this is both to get folks used to using the system. They usually have scouts that have been taking tests. They can take a test, scan it with our system, and then send it off. One, it helps us continuously get more data, so we're getting more and more and more data as we grow. But it also helps folks kind of get used to the systems and be able to benchmark it with their own crops. But we can also catch things like we saw some fields in Alberta last year that were super high in magnesium specifically, which you hadn't seen that before. So we got in contact and I was like, could you take a couple more tests in this field specifically to help round out our database, right? So there's a bit of that, just trying to seek rare conditions or novel conditions as we go. Yeah, I'm not sure if that answered the question or not. We kind of out left field a little bit. But you had a really interesting point too early on how can we get the data like geo-stamped and time located. That's a challenge that we didn't expect early on, but we've kind of had to build a platform for that too, and kind of think deeply about how can you do this type of analysis and not be completely overwhelmed with spreadsheets and trying to find coordinates and things like that. So we built a system to kind of if you have shapefiles, just drop them in directly, put where your sample locations are. And then when you're scanning with the system there, you just have a drop down, which is which field, and then which point in the field. And we found that the best way to be able to track all that, and then it's time-stamped automatically, and then it associates that with the GPS coordinates. And it also kind of gets people into the thinking of, these are my zones in the field, and I will consistently sample the same zones and not just do like a one-off in a random location. So you can do one-offs, but you'll have to like just manually kind of put a GPS. But the best way is, if you go a couple of times, even with corn, where you have maybe 2-3 applications, go before and then after a week to see uptake. It's probably the best way to do it is see the trend over the season, rather than just like one tissue test is kind of like a snapshot, but you're not seeing kind of the full
Well,
picture of the crop.
this fits perfectly long-term with variable rate application of nutrients. So,
Yeah.
So you want to set yourself up to fit into that, so you don't have to change your system when it comes along.
Well, and I think this approach, Xavier, is what we've been doing with soil testing for many years. And so the idea of geotagging and geolocating is exactly what we're already doing. We're just adding another layer to it. So, and hopefully this piece of information closes an information gap that we had before. Because sometimes the soil test doesn't always show what's actually wrong with the plant. So this is another piece of data. And at the same time, you layer a piece of satellite imagery on top. And then another piece is you take a camera like a multispectral camera or sensor like a Vivid or something like that, and you layer that piece of data on top. And then you layer on, what is the farmer actually doing? And all these pieces come together. And if people wonder why ag data has gotten nowhere to this point, it's because we're missing all these pieces, right? And once we can add them all together, now all of this ag data is going to start to mean something.
Absolutely, Chuck. And you think of like this is one piece, but you put the the crop status, the soil map, what's being applied. You can actually see like what's the uptake ratio and efficiency, things like that. And then one of the reasons we're super excited about the critical levels feature we're launching is, you can see your best performing fields and then see the nutrients, each nutrient trend over that field. And then you can get more specific for, what's the optimal nutrients for a russet Burbank in this exact field, right? And, bring it we need to bring in the weather and a couple other things. Like you can't be too specific, but just being more specific on nutrient levels. Recommendation that'll be needed for variable rate, right? If you want to get tailored recommendations basically from what's performed best in the past. And that's kind of up to the agronomist on the platform, but just being able to track it in some way.
Well, and I think where that leads to is, and we're doing some work on that with Honeyland and with others on what is the optimal rates of nitrogen or fertility at different times of the growth stage of the crop. It's amazing what data we don't have. For crops that we've been growing for 100 years, and then timing all this appropriately, as David talked about when it talked about sustainability and things. It's all about this timing of that application and when it's going to actually take it, and then you can start to model. Anyways, we can spend hours on this. Sorry about that.
Yeah, there's more unknown than known for sure. We're just trying to quantify this little piece of like what's the nutrient status along the way.
Excellent. Thanks so much for the presentation, Xavier. Appreciate it.
Thank you for the opportunity.
Of course.
You're muted, Dan.
Maybe before you move on, where are you located? Like, where's your office? Where do you guys actually park your butts and work on these fancy computers?
We have a research station in St. Henri, New Brunswick, and we have an office here in Fredericton to assemble the units and everything. So if anyone's on the East Coast and wants to go get some seafood and see the systems and visit, feel free. It's beautiful.
Okay,
in the summer.
you need a satellite office in the Holland Marsh in Ontario.
Agreed. Yeah. We've been working with some great folks there with the Muck Station in Guelph. And yeah, that's been our satellite office there, but definitely we need to keep working. Oh, I see Jeff here is on the call as well. Maybe Jeff, if you want to talk a little bit about your experience with the system there in the Holland Marsh.
Yeah, sure. It's just like Xavier says. He came out, taught me how to use it in about an hour. We were off and running. We did some potatoes. Last year we did our demonstration day where we showed some potatoes. People were really impressed. There were a lot of questions and interest around the Picetta system. This year we're further improving the onion model. We might start to dip our toe into celery and carrots as well. We have a really interesting onion trial. We're going to be doing like micronutrients along with some nitrogen fixing bacteria, trying to get as wide of a spread as data as possible so we can try to improve the picket system faster. While we're here, Xavier, I wanted to ask you, the demonstration was so good last year. This year, July 4th, do you think it'd be possible to have the system working on onions by then, just so we could give the growers around here a taste of what that looks like?
Yeah, I could say so. We'd have to have it in a beta mode, just with a tag on it that we're still working on it, but we can definitely show it off and get some results going. As long as we have an asterisk on it that it's still work in progress, but for sure we
Yeah,
can
for sure. Okay,
get
that'd be
going.
great.
Yeah. Yeah, so that's a good tag to for the July 4th uh demo or field day. Yeah, I'm trying to get there when it's going to be on the way to another show, but hopefully we can be there in person too and talk a bit more about it. Um, yeah.
Yeah, perfect. That'd be great.
Excellent. All right. Thanks, everybody. If you do think of any other questions, drop them in the chat there and we can circle back if we've got time, or we can connect you with Xavier. I saw he dropped his LinkedIn there, so I'm sure he's happy to continue the conversation off call. So moving forward to conferences, meetings, demonstrations, as we've already mentioned, we do have the demo days coming up in Bradford on July 4th and at the Simcoe Research Station on July 11th. So please keep those on your radar. We've also added a new event this week onto the list there, the Manitoba 4R Day at the Emily Innovation Farm on August 1st. That's in Grosse Isle, Manitoba. Link is there if you want some more information on that. Project updates. As you've all seen, we have started to fully integrate our new CRM. So the meeting invite for this week was sent out through that channel. We saw that some people went to their junk folder, so just keep an eye on that going forward. Are there any questions or concerns on that at the moment?
Just add that email to your safe sender list. You'll
Yes.
always get it.
Yes, absolutely. Thanks, David. Yeah, if it did go to your junk, you can mark it as like, no, I trust this, and it should help it not go to your junk in the folder. Go ahead, Chuck.
There's going to be there's a tentative date for the asparagus harvester in actual asparagus for June 24th. I will get more information. This is not going to be like a wide event, but they are talking about that. And then there's also a tentative date for the vineyard tour at the Innovation Farm at Cave Spring, the first full week of August. So I don't the exact date is not set yet, but it'll be either the 7th, 8th, or 9th. But more details to come on that. But if you just giving people a heads up that there's some stuff happening around that.
Perfect. Thanks for the info. Mike, I think you're cutting out quite a bit there. You're a bit robotic. Oh. All right. We'll just move on. Funding announcements and opportunities. We've added a new one at the bottom of the list there, the Thrive Academy Pre-Accelerator Program. So you can check that out. And then we'll head into the roundtable section of the meeting. So if anybody has anything to discuss or bring up, feel free.
The Grant, I know you're driving up to the marsh. Do you want to give an update as to some of the stuff that you did yesterday and the day before?
Yeah, actually, I'm back in the office because they got an inch of rain up there last night, so not heading there today. But yeah, so yesterday we were getting our VitaRover robot going. So there was a couple of representatives from VitaRover that came and visited us at Cave Spring there and got that little solar powered autonomous mower. Got it working and got it connected to its cloud platform and everything. So we're going to be running that over the next little while, just at the yard outside the office here at Haggerty Creek, just to test it out and kind of prove its efficacy, kind of thing. So got that going this week. The TED robot at Cave Springs, we're continuing to map out roads and get the navigation dialed in. We've mapped out a number of them and run them through the robot, and it's quite accurate so far. So we're just continuing to do that. And also this week, the farm droid, we mounted some of the new tooling that we developed onto it and run that through some passes to evaluate their efficacy, and it's working very well so far. So it's doing a much better job of managing the weeds and kind of slicing them off right below the soil surface. So since they got an inch of rain there last night, we'll likely start running it through its cultivation for the remainder of the season at the start of next week. And it'll kind of just keep going until the onions are too big for it to move through anymore. So. And our Oz robots are continuing to run at some of the farms they're located at. Through majority of Southern Ontario, it has been a very wet spring, so some of our deployments have been delayed getting out just strictly because growers have not been able to plant any of their crops, kind of thing. So some areas are 0% planted, I've heard, and some are 100%. So it's kind of everywhere in between, kind of thing. So this stretch of sunny, warm weather that's coming up is kind of shocking, and I was shocked that we actually dodged a rainfall event last night for once. So
I was just looking at the AgriCorps data this morning for 2024 planted crop, and it's quite shocking what low percentages we're at.
Okay. Perfect. Is there anything else that anyone would like to discuss or bring up?
So just from the project side, to give you guys an update, the scouting robot or the scouting project is close to doing our first scan, aiming to do that beginning of next week. The team at the University of Guelph has the control system going, and we have the mechanical side going now. And the hope is to get that all together on Monday, and then get our first scan and see all of our work from last year come together with a nice application map, hopefully. I'm so excited to get that going next week. And then yesterday, Jing is also on Haggerty AgRobotics for the season. If you haven't met him yet, he introduced himself a couple weeks ago, but at the end of the year, we'll have all the students present their work for the year, so you'll get to meet him again. Anyhow, him and I presented some of our ROI work that we've been doing this season, and we got some excellent feedback from Kristen, so we're going to modify and update that. And eventually we'll present that as well. And then the Nexus robot, things are moving in a positive direction with that robot too. It seems to be going up and running mechanically, or at least operationally now, and some of our staff are out there with the Nexus team getting trained and setting that robot up to be used hopefully next week as well.
Excellent. Thanks, Jason. All right. We have added a few new articles into the agenda there, in the article section. So please do take a look, keep up to date on stuff that's going on. If nobody else has anything, then I think we'll end the meeting a little bit early today. All right, perfect. I'll call the end of the meeting then. Thank you everybody for joining. Have a great weekend. And we'll see you next time. All right, take care.
See you then. You too. Have a good one.
Thank you very much.